Unit 6 review that I posted recently. It just kind of goes over what we did in Unit 6. So for the first number one, standard normal distribution mean mu equals 0, standard deviation 1. Determine the following probabilities, sketch the graph, or sketch the area on the graphs. Let's do the sketch first. So between 0 and 1.75. So is this not going to work? All right. So with a standard normal, our mu is 0, and it goes out from there 1, 2, and then -1, -2. So 1.0 would be here. 1.75 would be about right here. So we're finding roughly this area here. All right. The rest of it can be done on a calculator. So I'm going to do second vars. I'm going to do normal CDF. My lower is going to be 0. Upper is going to be 1.75. My mu is 0. My sigma is 1. And then the calculator does the rest. So about 0.46. Okay, or however you want to round it. For the next one, -1.29. So again, here's 0. -1.29 would be like right here. So we're talking this area here. My guess it's going to be something similar to letter A, but here we go. See normal. So number 2, lower would be -1.29. Upper would be 0. Yep, and about 0.40. Excuse me. The next one, so this would be letter C, anything above 2.31. So here's 0. This would be 1. This would be 2. So 2.31, it's going to, just that little bitty part right there. With these, the lower bound is going to be that 2.31. And our uppers can be everything to the right of that. So we're going to use that 1 second comma. So 1E and then 99. Keep those the same. And it's not, so 0.01. All right, and then for the next one, the last one, we're going to do, again, here's 0. -0.97 is pretty close to -1. So we're finding all this stuff and down. So second vars, 2. So the lower in this case would be the -1 E99. The upper limit would be that -0.97. And we get 0.1, let's say 7, if we're going to round. Okay, so that's number 1, A through D. On to number 2. I believe it says given a normal distribution, so a little bit different. Number 1 was dealing with standard normal. This is just normal. So this is going to have a mu of 47 and a sigma of 6.2. We're going to use the same feature on the calculator, except what we're going to do, let me clear this. Vars. Instead of using 0 and 1, so again, for letter A, less than or equal to 60, we're going to keep that -1 E99. We're going to change the upper to 60, and then we can actually change on our calculator the mu to 47 and the standard deviation to 6.2, so 0.98. All right, for letter B, we're going above 50, so we're going to use 50 as the lower, 1 E99 for the upper, those are going to stay the same. 0.31. Between 50 and 60. So lower is going to be 50, upper is going to be 60. 0.27. I'm sorry, actually 0.296, so about 0.30. And then less than or equal to 35. So that means the lower is going to be -1, E99. Upper is going to be 35. Still 47 and 6.2. And we get about 0.03. Now we could also change all of these to z-scores. So if you remember how to do that, we would, to calculate a z-score, we take the measurement, we subtract the mean, and we divide by the standard deviation. So for example, just in case, let's take letter D. The measurement would be 35. The mu is 47, and we would divide by 6.2, and that would give us a z-score of 35 minus 47 divided by 6.2 of -1.94, and then we could do the still the normal, and our lower would still be -1 E99, but this time we could use, what I say, -1.94, and then change the mu back to 0 and the sigma back to 1. We should end up getting the same thing, 0.03. Yeah. So you could change them to z-scores to standardize it, but using your calculator, you don't have to. Okay, on to number 3. Given the standard normal distribution with mu 0 and sigma equaling 1, determine the z value such that 5% of the area under the curve lies to the right of z. So in this case, let me kind of draw a little picture here. So what we have is the standard normal, right, where the middle here is the mu, which is 0. Okay, and what we're being given is that 5% to the right of z. So there's a z value here. We don't know where it is, but if we were to calculate to the right of it, that would be 5% to the right. So what we can do is, on our calculator, this is something called the inverse normal. So it's actually number 3. Okay, and the area would be the 5%, 0.05. Actually, since we're going to the right, you kind of have to think of it as, if 5% of it is to the right, 95% of it is to the left. And we're going to have to do the 95% because the calculator goes down. So that means over here would be the z-score, 1.64. Okay, for letter B, let me change to maybe pink. What we're finding is 1% to the left. Now, since it's to the left, it's going to be a negative z. And we can actually use the 1% in our calculation. So inverse normal, this time 0.01. And that's going to give us a -2.33 z-score. Go back to this one. So our z-score up here was 1.64. Right, now for 95% between these two, I'm going to switch to maybe green here. Right, so that means that there's two z values, a negative z here and a positive z here. 95% of the probabilities are, 95% of the data is underneath this green part. Now that means we have 2.5% here and 2.5% here. So when we actually do this, we're going to have to use 0.025 in our inverse normal, 0.025. That's going to give us the negative z-score, so negative 1.96. But then it's also going to be the positive of that because we split the 5% in half. So that would also be 1.96. Okay, and then number 4 is a word problem, I believe. An Amazon dispatcher in a large city found that the delivery time for packages is normally distributed with a mean of 28 hours and a standard deviation of 2. For a package selected at random, what is the probability that will be delivered in 24 hours or less? So to do this one, we're looking for the probability that x is less than or equal to 24. All right, we could convert this to a z-score or just go to our calculator and use normal CDF. Now, again, here's a little picture of what's going on. Standard curve. The average is 28. 2 hours are the standard deviation, so one standard deviation above would be 30, one standard deviation below would be 26, and so on. We're looking for 24 or less. So we're looking here down. Okay, what's that area? So the lower would be negative 1E99. The upper would be 24. And we're going to change, instead of using 0 and 1, we're going to use 28 and 2. And 0. Let's round to the thousandth, 0.023. Trouble with zeros. All right, so 2.3% that it will take 24 hours or less. So not that good of a chance. All right, in any case, what should be the guaranteed delivery time on all packages in order to be 95% sure that the package will be delivered before 28 hours? So again, what we're looking for, normal curve, 28. We're looking for maybe I worded this one wrong. I think I worded this one wrong. So let's skip letter B. That's not what I wanted to write. So let's skip letter B. My mistake. Sorry about that. All right, number 5. An environmental group did a study of recycling habits of a certain neighborhood. They found that 70% of the aluminum cans sold in the area were recycled. If 400 cans were sold today, what is the probability that 300 or more will be recycled? What is the probability that between 260 and 300 will be recycled? So it doesn't give us the mu, and it doesn't give us the sigma, but we can calculate this. The mu is the expected value. So in this case, it's going to be the percentage of the ones sold today. So 0.7, that's the 70%, times the number of cans sold, which is 400. So our mu is going to be 280. That's what's expected. Now, I don't think we talked about this a lot, came up in a few videos, but to actually calculate the standard deviation of something normally distributed, we're going to take the sample size, which is 400, we're going to multiply times that 70%, and then we're also going to multiply times 1 minus that percentage, so 0.3. Then we're going to take the square root of all that, and that's going to give us our standard deviation. So I'm doing that on my calculator, 400, square root of 400 times 0.7 times 0.3, so 9.2. Right, and then from there, we can look at this as a standard normal curve where the center is at 280, standard deviation of 9.2, and we want 300 or more. So 300 is about right here or more. So if we use second vars 2, And the lower bound here will be the 300. The upper will be all the way as far to the right as we can go, 1E99. This time the mu is 280, and the standard deviation is 9.2. So the probability of it being 300 or more is about 1.5%. So 0.15. All right, I'm going to change to red to do the second, between 260 and 300. So we're finding this part here, 260 and 300. So same kind of calculation, but lower is going to be 260, upper is going to be 300. Same mu, same standard deviation. 97%, 0.97. For that part. All right, sorry about that one. I forgot what I was trying to ask, but it came out weird. So that's kind of what we were doing before the coronavirus. So hopefully that is a good reminder.